So let's talk about what we need to know before we fill in a unit circle. First, we need to know that theta can be represented as either a degree or its corresponding radian. Further, we know that for each point along this unit circle, we are going to have a cosine for theta, and we will have a sine for theta. So when given a degree, we will have a corresponding, what we might call x and y as well, cosine theta and sine theta. Further, we also know that for each quadrant, beginning from our standard position along a unit circle, so our standard position is here, and moving in a counterclockwise or positive, we know that we have quadrant 1 is from 0 degrees to 90 degrees. Quadrant 2 is going to be from 90 degrees to 180 degrees. Quadrant 3 then is going to be all the way through to 270 degrees. And quadrant 4 is the remaining section. And what we should remember is that for quadrant 1, both cosine and sine, or x and y, are going to be positive. For each quadrant, that's going to change. Quadrant 1 is the only quadrant where both are positive. Oops. For quadrant 2, y, or sine of theta, y along the north and south pole, I guess you could say. So that is going to stay positive, but of course our x is going to be negative. Quadrant 3, they are both negative. And in quadrant 4, only y is negative. So with that information, we should be able to fill in the rest of this. And of course, I'm going to write 360 just below the 0. So the first thing I want to do is let's go ahead and list the corresponding radian. And we can finish up by placing the rest of our degrees in. So we know that at 30 degrees in the first section, then 45 degrees, 60. Then we have 120, 150, and right in between is 135. And below we have 180 plus another 30, plus 15, plus another 15 or 30 from 210. Then we have 300 degrees, 315, and 330. So let's go ahead and start filling in our radian. So the corresponding radian to 30 degrees, and if you're not sure, you can always check. So you can say 30 degrees, and I want to find its equivalent radian, so I would multiply by pi over 180 degrees. We can reduce the 0 and get rid of the unit measurement. 3 then goes into 18 6 times, So we would end up with pi over 6 as the radian. And again, for 45 degrees, we can do the same thing. Here we can just simply reduce our degree to give us a radian, and we're going to end up with 180 divided by 45, and we end up with pi over 4. And last for 60 degrees. And I really say last because the first quadrant is really all you need to memorize in order to have all the other points of a unit circle or corresponding reflective points along the circle. And we'll get to that in a minute. So for 60, I do know that it should be pi over 3, but we're going to say 60 is pi over 180 degrees. And of course, we can cross cancel, so we can get rid of the 0 and the degree. And 6 will go into 18 3 times. So it's pi over 3. And again, that's radian. It doesn't have a unit measurement. It is just simply radian. For 90, we are going to be at halfway between 0 and 180 degrees is going to give us pi over, let me see, pi over 2, I believe. And that's going to be 90 times pi over 180. 9 goes into 18, so that's going to be 2. Yeah, pi over 2. All right, now that we have all of that, let's finish the easy one. So at 0 degrees, we have 0 radian. At 90 degrees is pi over 2 radian. At 180 degrees, we are now at pi radian. And at 270 degrees, we are going to be 1 more than the denominator at 90 degrees. In other words, it is 3 pi over 2. And I can keep this all the same here. We'll just write that inside. So we have 3 pi over 2 radian. And then for 360 degrees, that's going to be 2 pi radian. Now, in order to figure out the remaining radian along this unit circle, again, I'm going counterclockwise. So from 60 degrees, which is pi over 3 radian, the reflective about the y-axis would be 120. So at 120 degrees, pi over 3 becomes 2 pi over 3. At for 45 degrees, the equivalent is 135 reflected about the y-axis, and it's going to be 1 less than the denominator, so it is 3 pi over 4. Then we have pi over 6 at 30 degrees. Its reflective is 150. And that is going to be 5 pi over 6. Down below, we can say that 30 degrees has a reflective at 210. Instead of pi over 6, that's going to be that will be 6 plus the 1 in the numerator to the pi, so it's going to be 7 pi over 6. And then we have 225. Its reflective is going to be 45 degrees, or pi over 4. So it's the denominator 4 plus the numerator 1. So that's going to make it 5 pi over 4. And at 240 degrees, that will be at 60 pi over 3. So we're going to do a denominator of 3 plus 1 gives us 4 pi over 3. And then we do the same thing for the last quadrant. We're going to use the second quadrant to help us with the reflective for the radian. And we're going to add the denominator to the numerator. So it's 6 plus 5 gives us 11 pi over 6. For 315, that's equivalent, that's reflective of 135 degrees, or 3 pi over 4. So we add those together. 4 plus 3 is 7. That gives us 7 pi over 4. And then we have 330 degrees is actually 5 pi over 6. So that one is 11 pi over 6. And let's erase this at 300. So at 300, it's reflective. It's straight across from 300 is 120 degrees, and that's going to give us 5 pi over 3. And that makes a lot more sense. So really, you just need to know the first quadrant. And from the first quadrant, you can figure out how to fill in the rest of them by just remembering that the second quadrant is going to be the reflective radian, but one less than the denominator. Quadrant 3, using quadrant 1 to fill in quadrant 3, it's going to be the denominator plus 1 for the numerator. Quadrant 4, you will then use quadrant 2, and you will do the same thing, adding the denominator to the numerator to give you the value for each one of those. So the last thing that we need to do is just to simply fill in our cosine and sine thetas. We'll use black for that. And again, just memorizing the first makes it a lot easier. So we'll say that for the first one, we're going to have the square root of 3 over 2. And for sine, it's just going to be 1/2. At 45 degrees, that's just square root of 2 over 2 and square root of 2 over 2. At 60 degrees, it is 30 degrees, but reversed. In other words, it is going to be 1/2 square root of 3 over 2. And of course, at 90 degrees, 180, 270, 360, or 0 degrees, that's really simple. Anytime that x is at 1, then sine theta is going to be 0. At 90 degrees, we would say that when cosine or x is at 0, then sine theta is 1. At 180 degrees, it's just the opposite. It's going to be -1 and 0. And at 270, it is simply going to be that 0 and -1 for sine theta. So to finish this up, now that we know 30, 45, and 60 degrees, and we also have listed for each one of these quadrants what cosine and sine should be as far as the actual sign goes, we can simply relist each of these. So we can just go through and list out 1/2 square root 3 over 2, square root 2 over 2, square root 3 over 2, and 1/2. And then again down here, you can just continue on You can continue doing this all the way across, but essentially we're going to end up with the exact same values. The only difference that you're going to have is the sign that you put in front. So for every cosine in quadrant 2, it will need to be negative. But in quadrant 2, sine theta is positive, so we can leave those. So that is your set for quadrant 2. And then again, it's going to be the reflective from quadrant 1 to quadrant 3. So for 210 degrees, it should be square root 3 over 2 and 1/2, but they're going to be negative. So the sign is negative. So if we just follow the line at 30 degrees through the circle, we end up at 210 degrees. And we will just say square root 3 over 2 and 1/2. And in quadrant 3, of course, it's negative and negative for both. And then square root 2 over 2, negative for both. And last, straight across from 60 degrees to 40. So we just we'll write negative 1/2 and negative square root 3 over 2. And the same thing. This time we can use the sets that we created in quadrant 2. So from 120 degrees straight across to 300 degrees, we're going to write the same set. Let's see here. So we have 1/2 square root 3 over 2. And actually, for quadrant 4, your cosine theta, or 1/2, is going to be positive, but sine is negative for this set in quadrant 4. So we have a positive and a negative square root 2 over 2. And last, we will have square root of 3 over 2 and negative 1/2. And that is your unit circle. Hope that helps. Thanks for watching.